In these problems, we're trying to solve equations for a variable. So you see in this one, there's an x here. It's that x we want to find out. We want to know what that x is. To do that, we have to get x alone on one side of the equation and everything else on the other side. Once we've done that, we can say that's what x equals. In an equation like this, where you've got an x term, so there's the x, it's multiplied by 5, so that's a complication, but that's our x term. And then we've got another number hanging out here, this -6. So the first step in getting x alone is just getting the x term alone on one side of the equation. So we want to get rid of this -6. Well, how do we do that? Well, in algebra, if you have an equation, you're allowed to do anything you want to it. Add, subtract, multiply, divide, take square roots, as long as you do the same thing to both sides of the equation, both sides of the equal sign. So this is a -6. I want to do the opposite of that to make it go away. The opposite of a -6 or a -6 is a +6. So I could say, I'm going to add 6 to this side of the equation. If I do that, I have to do the same thing on the other side of the equal sign. So I would add 6 over here. So on this side of the equal sign, we have 14 plus 6. That's 20. On this side of the equation, we have 5x minus 6 plus 6. Well, -6 and +6, they come out to 0. So what that does is it basically makes it disappear, which is exactly what I wanted. So now we just have the 5x on that side of the equation. So we've gotten the x term alone. And in typical algebra equations like this, often you're adding or subtracting first to get the x term alone. And then you arrive in this situation where there's something multiplied by the x. And we want to undo that. And we can undo this multiplication, this 5 times, by doing the opposite of multiplication. And the opposite of multiplication is division. So we're going to divide by 5. 5 divided by 5 is 1. That would be 1 times x. So that's going to leave the x alone. You can also think of it this way. The 5's would cancel, leaving just the x. But I divided this side of the equation by 5. I have to do it to the other side of the equal sign. So this gets divided by 5. So rewriting this, 20 divided by 5, well, that's 4. And over here, 5x divided by 5 just leaves the x. Aha! And we've got x equals 4. The x is alone, so that is our answer. If you want to check whether that's the correct answer, you can take this 4 and plug it in back for x right up here in our original equation. So that would be 5 times 4 minus 6 equals 14. And then calculate that and see if it's true. 5 times 4 is 20, minus 6 is 14. Yeah, so 14 equals 14. So that is the correct answer. All right, let's try a more difficult one. And this really is the same kind of equation. We have an x term. We have another number hanging out here that we need to get rid of. And then we have a number over here on the other side of the equal sign. The problem is the fractions. And fractions can be difficult sometimes, or seem difficult. My approach to dealing with fractions like this is to get rid of them as quickly as I can. And the technique I would recommend is to look for the largest denominator, the number on the bottom of the fraction. 12 is our largest denominator here. The other denominators, 4 and 2, are factors of 12, so this is going to work out perfectly. What I'm going to do is multiply both sides of the equation, as long as I do it to both sides, multiply by 12. As long as I do it to both sides, it fits with the rules of algebra and it shouldn't cause any problems. And because I've got fractions here, I'm going to write my 12 as 12 over 1. And we're going to do some multiplication of fractions. Let's do this side first. I think it's easier to grasp the multiplication. When you multiply fractions, you multiply across the top. So that's 1 times 12 is 12. And, oh, we've got a negative sign here, so I'll put that up there. And then 2 times 1 is 2. So we have a negative 12 over 2. Well, 12 divided by 2 is just 6, so this is a negative 6. So that is what's going to go in that spot in our equation. We've got 2 more problems to do like that before we can get rid of our fractions. this 12 over 1 has to be distributed. So you multiply it here, and you multiply it here. So let me just set up those problems. 12 over 1, that's this guy, times this guy, 1 over 12, and that's also times x. And when we multiply across the top and across the bottom, 12 times 1 is 12, 1 times 12 is 12, we get 12 over 12 times x. Well, 12 over 12 is just 1, so that's really just x. That's why I chose 12, because I saw 1/12 here. I knew that would erase the 1/12 basically, and we'd just be left with x. So this right here is x. This right here is -6. We've got one more to do. That's 12 over 1 times -1/4. So 12 times -1 would be -12. 1 times 4 is 4. 12 divided by 4 is 3. So this is a -3. And that's what's going to go right in here. So if I rewrite this equation, I've got x, I've got a -3, then comes my equal sign, and then a -6. Now this should be quite a bit easier to solve. I've got a situation where I've got my x, there's nothing divided or multiplied by it now, so that's great. But I've got this other number hanging out here. I want to get rid of this. It's a -3. I want to do the opposite of -3, so I'm going to add 3. But if I add 3 to this side of the equation, I have to add 3 to this side. And let's do the addition here. So a -3 plus 3, that's just 0, so that I get rid of that. That leaves just x on that side of the equation. And then I have my equal sign, and then -6 plus 3, that's going to be a -3. So that is our answer, x equals -3. If you want to double check that that's the correct answer, you could go up to this original equation. If you put a 3 in for x, you'd get 3 over 12. That would be, -3. You get -3 over 12. That would be a -1/4. So a -1/4 minus 1/4 would be a -1/2. Aha, and that's what we've got over here. So you'd have -1/2 equals -1/2, and it works. So that is a little bit about solving algebraic equations.